Imagine standing on a world where the sky glows orange, the ground beneath your feet bubbles like a volcano, and the weather report predicts a storm of molten rock. Welcome to K2-141b, an exoplanet so extreme that scientists call it a lava world. Here, oceans are made of magma, winds howl faster than the speed of sound, and stone itself evaporates into the air, only to rain back down as liquid fire. Today on SPACEWIRED, we'll explore the discovery, the physics, and the nightmare conditions of this real planet that defies imagination. K2-141b was first identified in 2018 by NASA's Kepler Space Telescope. It lies around 200 light-years away in the constellation Aquarius. To put that into perspective, if you could travel at the speed of light, it would still take you 2 centuries to get there. This planet is what astronomers call a super-Earth, larger than Earth but smaller than gas giants like Neptune. But that's where the similarities end. From the start, scientists knew something was unusual. The planet's orbit is just 6.7 hours long. That means a year on K2-141b, the time it takes to circle its star once, is shorter than a single workday on Earth. The reason for this ultra-short orbit is that K2-141b is hugging its star, orbiting so close that it's practically skimming its stellar surface. This proximity creates conditions unlike anything we've ever experienced. Like many close-orbiting worlds, K2-141b is tidally locked. Just as our moon always shows one face to Earth, this planet always shows the same face to its star. That means one side of the planet is in permanent daylight, while the other side is in eternal night. The day side is a world of fire. Temperatures soar past 6,000 degrees Fahrenheit, hot enough to melt steel and vaporize rock. Meanwhile, the night side freezes at around -300 degrees Fahrenheit. This split personality makes K2-141b one of the most extreme planets ever studied. On Earth, we have the water cycle. Water evaporates, forms clouds, and rains back down. On K2-141b, the same process happens, but with rock. Here's how it works. The extreme heat on the day side vaporizes rock directly off the planet's surface. Those rock vapors rise and form clouds high in the atmosphere. When the vapor cools, it condenses into molten droplets that rain back down as lava. This is called the mineral cycle, and it's one of the strangest weather systems ever discovered. Imagine a thunderstorm, but instead of raindrops, it's streams of liquid stone falling from the sky, splashing into oceans of glowing magma. And those oceans are vast. Instead of seas filled with water, K2-141b has lava oceans stretching for thousands of miles. Some may be hundreds of miles deep, with molten rock constantly churning under the fierce heat. The wildest part? The atmosphere doesn't stay still. The temperature difference between the day and night sides drives winds at 3,000 miles per hour, nearly 3 times the speed of sound. For comparison, Earth's jet stream flows at around 200 miles per hour. These winds would shred anything in their path. On the night side, things are just as extreme, but in the opposite direction. With no sunlight, temperatures plummet, and some scientists believe the atmosphere itself could freeze solid. Minerals that evaporate on the hot side may be permanently trapped on the cold side, slowly shifting the balance of the planet's surface chemistry over millions of years. So why does this planet matter? Beyond the jaw-dropping visuals, studying K2-141b helps scientists push the boundaries of what we know about planets. It proves that the physics we're familiar with on Earth, like the water cycle, can happen in radically different ways elsewhere. Instead of water, it's rock. Instead of rainstorms, it's lava storms. It also gives us insight into how tidally locked planets behave, which is important because many exoplanets orbiting close to their stars, even potentially habitable ones, are tidally locked too. Understanding the climate on extreme worlds helps us model the climates on more Earth-like ones. Could life exist here? Almost certainly not, at least not life as we know it. Any carbon-based life would vaporize instantly. But some scientists imagine exotic silicon-based life that could, in theory, survive in such harsh conditions. It's unlikely, but discoveries like K2141b remind us that life may not always follow Earth's rules. K2-141b is a reminder that the universe is stranger than fiction. A planet where it rains lava, where oceans glow with magma, where winds scream faster than bullets, and where one side burns while the other freezes. Earth has hurricanes, volcanoes, and deserts, but nothing compares to this. The next time you complain about the weather, just remember, at least it isn't raining molten rock.